So now we take our factoring full circle back to grouping, where we're going to need our difference of square strategy. The directions say factor completely. So at first glance, our factoring completely steps are always step 1, look for GCF. This doesn't have a GCF. And then step 2 is the one we just learned, which is the difference of squares. And we're going to learn the sum and difference of cubes in a little bit. But we're going to be looking for difference of squares. And then the third step would be our X group method. And then the fourth step is grouping, just grouping. Now, grouping these is this problem, and that's because after you look for your GCF, the rest of these are by term. So my step 2, step 3, step 4, these are all just done by how many terms you have. If you have 2 terms, you're looking for difference of squares. If you have 3 terms, you're looking to do X grouping. And then if you have 4 terms, you're just doing grouping. So we know that this is a grouping problem. I mean, yeah, the directions say it, but you're not going to see those directions every time. So here, we'll just see factor completely on a set of worksheet problems, and our job is to just recognize what type. Well, here, because there's 4 terms, we cut it in half. And we look for a left-hand GCF and a right GCF to do grouping. And the left-hand GCF is x squared. And so the way that we factor it out is we divide each term by x squared. And dividing x to the third by x squared should give me 1x, x to the 1. And then dividing 2x squared by x squared should just give me a minus 2. So pretty straightforward so far if we have practiced our grouping. The second one, we have to be careful because there is a minus sign. And so we have to be intentional about getting this x minus 2 binomial. And so to do that, I actually need to factor out a negative. So that's a struggle for some. So we got to pay attention that we can't just bring it down. It needs to factor out a negative. So you actually put a -1 and put that in front of parentheses because you're going to divide each term by -1. So negative x divided by -1 should give me a positive x. And then 2 divided by -1 should give me a -2, which I have to have for the grouping to work. I have to have these binomials be the same. So now I can factor out my common binomial, which is x minus 2. And when I factor it out, I'm dividing it out. So I divide each term by x minus 2. And what's left in the first one is x squared. When I divide the second one by x minus 2, what's left is a -1. Now, we might run and type that in and think that we're done, but we're not. What happens is if we're paying attention when it says factor completely, we have to look at each layer of our factors and say, is this done? Well, this is linear. If you ever have a linear, which means if you have x to the first power, yes, it's done. But if you have a quadratic or more degree, 2 or higher, you might have more to go. And this one you do. X squared minus 1 is a standalone factor problem. It's a difference of squares problem. So what we have to do is further factor this and recognize, oh, this is just x that's being squared, and this is just 1 that's being squared. So I don't have to be afraid of it. I just have to keep factoring it. So it makes 2 parentheses, 2 more linear products that are conjugates. It's x and 1, where x is my a, because x is being squared. That's your a. And then 1 is being squared. That's my b. And so I have x and 1, x and 1. So I do a conjugate pair, 1 and -1. So this x squared minus 1 needs to rewrite to be x plus 1, x minus 1. So our factored form on the left needs to be rewritten completely, where this second set gets rewritten. Now that first x minus 2 stays the same. And then these 2 terms go next to it in place of the x squared minus 1. So we write x plus 1, x minus 1. And those 3 linear factors leave it as fully factored or factored completely. So again, if you ever you get exponents of 1, then you know that that's fully factored. If you have anything higher than 1, you've got to check to see if there's a subsequent method of our 4 factoring strategies to keep going. All right, so we've got another factor by grouping problem. It's going to work out similar to the last, where we recognize there's 4 terms. There's no overall greatest common factor, so we go ahead and split it in half. Look for a left-hand common factor, so ignoring the right-hand side for a moment, and that's going to be an x squared, very similar to the last problem. And so we divide each of these by x squared. That's going to give me x. Divide this by x squared, and that's going to give me plus 4. And the right-hand side is a little bit more obvious that you're going to end up factoring a negative because they both are negative. Last time we had to be intentional, even though they didn't have it technically in common. We had to force it. But this time they do have a negative 25 in common. And so when I divide the first one by negative 25, I'm going to get a positive x. Divide the negative 100 by negative 25, and I get a positive 4. And then these are both in common, which means we can factor out our common binomial factor of x plus 4. And if I divide it out from each term, x plus 4 here, the x squared will be left, so I got to put parentheses with my result of division. So I have x squared, and then divide this one by x plus 4, and I get negative 25. And again, always if you have a degree higher than 1, you want to check to see if there's subsequent factoring that needs to happen. There's 2 terms here, which means the type of factoring I look for is difference of squares, and sure enough, that's the difference of squares. So I'm going to write the whole problem up here, x plus 4 times x squared minus 25. And I'm going to draw 2 arrows this time with parentheses. This is how I would do it if I was doing the problem and not giving a step-by-step tutorial, because I would just see, hey, that's the difference of squares. So all my brain says is what square gives me the x? Well, that's x. And what square gives me 25? Well, that's 5. So I just write x plus 5, x minus 5 for the difference of squares. And that is the final fully factored result that I'm going to put in my box to be done. And again, once you get to linear, each factor has a degree of 1. That's when you're done factoring and you don't have to keep working for subsequent factoring to be completely factored.